Okay, so extra lesson, quadrilaterals. We've done this already, and this is what we did up there, and you got it on your sheet already. So the next part I'm going to go to is this. This is my family tree. Okay? So out of all of those up there, what do you think should be at the top? Yeah. What's that? Quadrilateral, definitely. Why is quadrilateral? Because it's everything. Okay, so quadrilateral, very good, Bryn, is going to go at the top of my family tree. Nice job. Quadrilateral. He's like the head honcho of all of them. All of them are quadrilaterals. Okay, so then let's look through the rest of the, what do I have, 5 up here yet? 1, 2, 3, 4, 5. What are some up here that are related for sure that you know? Okay? Right? And okay, so we know these 4 are truly related, rectangle, parallelogram, square, and rhombus, because of what again? They have what common feature? 2 sets of parallel sides. So what's the one that's kind of the oddball out? Trapezoid. Okay, so trapezoid is going to come off a quadrilateral like this. Okay, because he's really not related to the other 4. Now make sure you make your arrows the way I have them, because that's going to be important in a second. That's going to be really important in a second. So then I'm left with rectangle, parallelogram, square, and rhombus. Now out of those 4, which one do you think should be the top one? Rectangle, parallelogram, square, or rhombus? Square, rectangle. Which one could all 3 of these be? Or all 4, which one could all 4 of them be? So a parallelogram can be a square? No, okay, no. Can a rectangle, let's see, can a rectangle a rhombus? No. But what do we know about a rectangle that a rhombus does not have? No. 90-degree angles. Okay. So which one do you think should be the top one of all of these? Yeah. I agree. Parallelogram should be the next. Because could these 3 things all be considered a parallelogram? They could. All 3 of them could be considered a parallelogram. So here's my next one. Maybe you aren't going to get it yet, but that's okay. You will. Just relax. So then I'm left with rectangle, square, and rhombus. Which 2 out of these 3 are not really alike? Rectangle, square, and rhombus. Why rectangle and rhombus would you say that? Why would you say? Okay. But why, if I asked you if rectangle and rhombus, they're alike, they have the 4 sides, but they have the 2 sets of parallel sides, but what are they not, why are they not really alike? Okay, all their sides aren't congruent, and what other thing do they not have? Right, they don't have 90-degree angles. So those 2 things, they're related, but not as closely. So what's going to happen then is, guess what? That's what it's going to look like. Because I know a rectangle can't be a rhombus, so they're not really connected. Just wait. Then we have square left. What do you know about a square? Hold on. What do you know about a square and a rectangle? 90 degrees. Their side lengths. Can a square be a rectangle? Yes, but can a rectangle be a square? No, because a rectangle you have to have 2 different side lengths. What about a square and a rhombus? How close are they? 4 equal sides. They have same side lengths. Remember how on the bottom I showed you that a diamond can be a rhombus too? So really, can a square be a rhombus? Yeah. So here's the next thing that's going to happen. Are they both? Is a square related to both of them very closely? You know, these arrows are a big deal. The reason why these arrows are a big deal is because of this. If I would say, what kind of quadrilateral is a square? What kind of quadrilateral is a square? What would you tell me? What would you tell me? Now look at the arrows. What kind of quadrilateral is a square? Are all these things quadrilaterals again? Yes. Yes. What else? It's a rectangle, it's a rhombus, it's a parallelogram, it's a quadrilateral. Is it a trapezoid though? No, because they're not connected. If I'd ask you what kind of quadrilateral a rhombus is, what would you tell me? And you just follow the arrows. You just follow the arrows. So if I asked you what kind of quadrilateral a rectangle was, what would you tell me? A parallelogram and quadrilateral. If I asked you what kind of quadrilateral trapezoid is, what would you tell me? Just a quadrilateral. It's nothing else. Do you have any other arrows down below with trapezoid? No. So that's what my family tree looks like. See how closely some of these things are related? You probably have never looked at shapes this close before, or four-sided shapes anyway. They're all like brothers and sisters. It's pretty cool. If you really look at their attributes, they're really, really closely related. Okay. Any questions? Did you guys have fun doing that? It was kind of fun. I think it was fun. That's kind of fun. Okay, so the next thing you need to have on your notebook, okay, I'm going to do a few other things. Next thing you need to have in your notebook is this. Quadrilaterals have a sum of 360 degrees inside of them. Remember how we talked about a triangle is 180? Well, quadrilateral, four-sided shape, no matter what sides, if they're parallel, if they're equal, they all have 360 degrees inside of them. Quadrilaterals all have 360 degrees inside of them. Now some of you might say, why? And it's actually really, really simple. If you take any quadrilateral out there, you can split it into two triangles. And two triangles, 180 plus 180 is 360. That's why you split it into two triangles. Another thing, too, you all know a circle is 360 degrees, right? Like, if you watch the Olympics, they were talking about, like, 180s and 360s, and everybody, did you guys see that, like, with the snowboarding? Okay. So, like, when you turn a whole turn, it's called a 360. And let's say this was like a map, and you started here, and you went to this corner, and then you turn this way, and you went to this corner, and you turn this way, and then you went to this corner, and you turn this way. You really technically made a circle. So that's why all of them are 360 degrees, because if you would walk inside of that shape, you're basically making a circle, 360 degrees. So quadrilaterals and circles have 360 degrees. Now let me show you how this is going to work today. Do you remember how we had to find the missing angle of a triangle? Okay, so we're going to do the same thing today, only with a quadrilateral. So for example, you're going to be given a quadrilateral with three side lengths, or three angles that you know, and one you don't know. And you need to figure out what your x or your t or whatever your variable is. You guys can give it a whirl if you want. You can try it. Figure out what you're missing. I don't know how you do it, if you want to add all three, if you add two and then a third one, however, whatever easiest for you, I don't care. Let's see, this one before, I just did this. So when I added all three of mine together, I got 285. I don't know what you guys got. We're still working on it. But once you add those three together, what do you got to do with that last? What do you got to do with the last step? Not quite. You got to take 360 minus, remember it's not 180 because we're not talking about triangles today. We're talking about quadrilaterals, so it's 360 minus 285. 5, 7, should be 75 degrees. And I know it's not drawn according to scale. I just threw numbers in there. Doesn't mean it's got to look alike. Okay, doesn't matter. All right, any questions so far? Any questions so far? All right, do the last one for me, then I have a few more things I need to show you. Do the last one for me, and then I have a few things I need to show you. Draw a picture of it. Do what you need to do. Let's do 123, 70, 72. All right, can we handle something like this today? So far? Not too tricky. Not too tricky. Need another second, anybody? All right, answer. What'd you get? Raise your hand. What'd you get for an answer? Christina? 95. Nice job. 95 should be your answer. Good job. Can you do stuff like this? Okay, I'm going to take it one step further now for you. I'm going to draw a picture for you, and it's going to look like this. What kind of shape is this? Quadrilateral. How many sides are there? 4, right? It's not one of those up there because I didn't put any equal side lengths. Well, let's pretend this is straight, shall we? That bothers me. Okay, what I'm going to do is I'm going to put, what's the matter? It's okay, I don't need it to be straight. I don't want that one to be straight. Because I have a square rectangle, and I don't want it to be a square rectangle. So, I'm going to put different angle measures in here for you, and I want you to watch. So this is going to be, what's that angle measure? Okay? And let's say this is 70. And let's say this is 110. And let's say this is 2x plus 2. My job is to solve for what now? X. Okay, so now before I do that, what do I know about all these angles? What do they have to add to? Okay, 360, good. Now this is what you're going to have to do. We got to add all of them together, so don't forget 90. A lot of you forget 90 because it's not there. I like to start with whatever my variable is. You don't have to. So 2x plus 2 plus 90 plus 70 plus 110 equals 360. So make sure you get that written on your paper, and then we're going to stop for a second. Everybody got this written down? Make sure it's equal to 360 and not 180. Because then you're talking about triangles, and we're not talking about that. Next thing you're going to have to do is what? What do you think? Yep, you got to add all together those, because we're going to make it as simplified and as small as possible. So, it'd be 110, 70, 90, and 2. 272. You're right. I think, right? 272. So then it's going to be rewritten like this. Can you solve that? Yeah, it's a two-step equation. You know how to solve that. Solve the rest of it now. Figure out what you can get for x. Bo, question? You got the answer? Okay, just one second, please. Nice work, you guys. I see some good answers. What'd you get, Bo? Should be 44 because once you subtract, you should get 2x equals 88. You got to divide by 2 then. Don't forget that. X equals 44. Okay, we're going to do one more of these. There's my awesome shape. Let's say this is 90. Let's say this. without a whole number. Drake, do you need another notebook? Yeah, you were going to have to get one. Yep. If you need more pages in your notebook, you better get one. You better get one because we got a lot more stuff to do this year yet. Get a new notebook if you need it. This one away. Do not throw it away. Keep working. The only thing that's different here is the one you got to subtract. That's the only thing that's different. I'd give you even a harder one if you want. What? You have plenty of time. It's not hard. Read right what these are. Or so you can add all those, or you can count it either or. You can count it as adding those up and then subtracting 2, or you can add all the positives and add that like a -2. You could do either one. Okay, those of you who are done, I want you to look at this and see if you can find an even easier way to solve this one. There is an easier way to solve this one, way easier way. So look at it. Just brainstorm and look at it a second. I don't ask you to do this often. But see if you can find an easier way to solve this one without adding up all the sides together, because there is an easier way. Think about what you know about angles. Just wait. I just want you to think about it. Think about what you know about angles. Think about what you know about vertical angles. Time out. What did you get for an answer? 8. Okay, now watch. What do you know about angles? If these two are the same, then these two have to be equal to each other. So another easier way for this one, this doesn't work for everyone. You could have just solved that, and it would come out to the same thing. Aren't you proud of yourself? You found 2 different ways you could solve a problem. It's pretty cool. It's cool. You want a harder one? Yeah. All right, one more. We got time. We got time.